Hey everybody, thanks for coming. Raise your hand if this is your first time at a Java meetup. Scott, put your hand up. All right, got one. All right, well, thanks for coming. Yep. Feel free to grab pizza and drinks out of the fridge, and hope you get something out of this. We will be giving away an IntelliJ key at the end, so that's good for 1 year of any IntelliJ product, probably about a $300 value. So stay tuned for that. I'll give it away randomly to anybody who wants it. Big thanks to our sponsors, McGregor Partners. They are right across the street from us. They're a logistics company, and they're always looking for smart engineers. So give them a look up if you're in the market. Also, thanks to our sponsor here, Watermark Ed. And that's where I work. We're also looking for smart Java engineers, so hit me up if you're interested. And I'm going to hand it over to Adam now. He's done a few presentations for us before, so he's not a newbie here, he's a veteran, and he's going to be talking about Hibernate in depth. So big thanks to Adam for doing this, and stay tuned for some ORM.
All right, just 1 second. I got these weird red lines of death here. All right, it's the recording software. Sorry about that. All right, so my name's Adam Weigold. I work for a little company called TrustedChoice.com. I'm the VP of Engineering and Chief Architect, which is a fancier title than it is. Previous to that, I worked a long time for Toshiba Medical, where we heavily used Hibernate a lot for our web services. So that's where I gained most of my experience, and thought share with you some things that I've learned. All right. So first off, this presentation has the word in depth in it. And the topic of high performance Java persistence could probably take weeks of full day presentations. So I want to spare you of that. So kind of my goal of this is to go beyond just simple hello world with Hibernate and Java, and go into how entities are actually managed and some common pitfalls and anti-patterns that I've seen in my career. Just a show of hands about how many people have used Hibernate or at least are comfortable, have seen Hello World with it. Okay, yep, JPA too. That's good. Okay, so that makes me a little more confident that I can skip over the basic stuff and dig right into some things. And then before I start, I really want to credit this publication by Vlad Mihalchia, and I brought it right here. A lot of text in this presentation I even copied verbatim from his book. Vlad, he was recently named a Java champion a few years ago, and a lot of it was through his blogging and advocacy on Hibernate. He's worked inside of Hibernate core. He knows it very well. And in fact, whenever I come across a Hibernate annotation I've not seen or haven't seen in years that one of my engineers wrote, I will usually, instead of just Googling it and getting the documentation, I'll Google it and add the word Vlad to it and find out immediately if it's good or bad. Because the thing with Hibernate is it lets you get away with anything you want, so it can work in any database. It doesn't necessarily mean the things it lets you get away with you want to do. So I highly recommend you check him out whenever you have questions. All right, so I'm going to go over a couple basics that are really important before I get into the later sections. So JPA, what is JPA? So JPA is simply just a specification. There's not a JPA library out there. It's a specification for JPA providers to implement. So what it does is it describes the interfaces and the standard ORM metadata a client operates with. So this is dealing with persistence in Java. And JPA, although not exhaustively, it does explain how all the specifications ought to be implemented by JPA providers. So that's what JPA is. So when you see JPA code, know underneath that there's some sort of JPA provider or vendor actually implementing the spec. Hibernate, what is it? So Hibernate was actually already, back in the olden days, when I kind of started my career, it was a full-featured Java ORM even before the first JPA specification was first released. So it already existed out there, and it was already massively popular. It does implement the JPA specification, but underneath, it does retain its original native API. So it implements the specification using how it has always worked. And this is a lot for backwards compatibility as well as some of the performance enhancements it provides. And lastly, it does include a lot of non-JPA compliant features, which you can absolutely use to target high-performance data access layer requirements. So when you think about JPA, that's a standard, as well as Hibernate to some respects, that really allows you to be portable. And this is this great idea where I can swap out my database vendor, I can swap out my JPA provider, and my code should still just work. But I kind of want to caution you with that. So first off, if you're just writing pure JPA, there's a lot of implementations that can hinder your app performance, and you're only getting this portability aspect out of it. A couple examples, and I'm not going to get into them. So there's a couple features in the JPA spec, like flush mode type auto, fetch type eager, which does absolutely the wrong thing, what you don't want to do. So you want to be careful just trying to code directly pure JPA. And the other thing I really want to stress is, in reality, when you're working in your career and you encounter these applications, you're probably going to 9-to-1 face data access performance issues rather than issues for migration of vendors. I can think of only one case where that portability even came up in my career. And even in that case, there were so many tweaks that were done here or there for different vendors that I had to deal with it anyways. So just remember that portability is a cool feature. You should go for that, but don't trip yourself up just in the name of portability. That's not what's of value here. All right, and then another base concept that I want to make sure we understand before going into this is the idea of a persistence context. So what a persistence context does is it captures entity state changes, and during flushing to the vendor, it translates them into SQL statements. I'm going to go into what these entity states are in a bit, but that's the concept of a persistence context. This is usually wrapped up in some sort of transaction, however, it doesn't have to be. And the JPA Entity Manager and the Hibernate session interfaces are basically gateways towards your underlying persistence context. And they'll define all the state transition operations. So these are the entity state transitions, and I'll go into more detail, but both JPA and raw Hibernate have these same exact transitions and the same exact allowed changes between the transitions. Now the operations between them to achieve those transitions actually differ. There's different calls that are made available, but it does always work this way. So you always have new transient entities that become managed. They only make it to the database after they've become managed. You can only retrieve from the database managed entities. And then the one exception to be able to go to the database without being directly managed is a removed entity. But that's always going to come from a managed entity. All right? So what is the new state? This is a newly created entity which is not mapped to any database row. So when you have a database plain old Java object that's mapped with Hibernate bindings, but it's not in your database, and you just call new on this object, it is a transient entity at that point. Now, once it becomes managed, the persistence context will see that, and it will issue an insert statement at flush time when it's appropriate. So when the persistence context does its synchronization process with the database vendor, that is where an insert will be issued. Managed. Now this is the most important state. So persistent entity is associated, I have a typo there. A managed persistent entity is associated with a database row. So that means that there is some sort of row that is either in the database or is about to be pushed to the database that maps to. And furthermore, that entity is managed by the currently running persistence context. This is very, very, very important to remember. So the persistence context is looking at state changes to this entity by a process called dirty checking. I'm actually not going to get into how that process works right now, just because I had to find places to cut in this presentation. But just note that any managed entity that has any changes done to it will be caught in this dirty checking mechanism, and the persistence context will propagate that to the database as update statements when it's ready to flush. Detached. So if you have some managed entities and the currently running persistence context associated with it is closed, at that point, all of those entities are effectively detached. So what this means is the state of these entities, you are no longer guaranteed to be in sync with the database. And Hibernate actually will do a lot to enforce that. If you try to make an update to a detached entity, it's going to say, unless you have some concurrency control, which I'm not going to get into with add version fields, it's not going to let you make those updates because it has no way of knowing if that still is representative to what's in the database. And so I just kind of went over this. Successive changes to this are no longer tracked, and there's going to be no synchronization going to happen. So do these make sense to you guys so far? Because this is really important to know to understand some of the things I'm going to talk about in the next few slides. I'm seeing a lot of yeses. Now's the chance. Go. Okay. Any? Sure. So the question was understanding the difference between an entity and an object. So an object, as you all know, is just a structure representing a piece of memory that you can typecast in Java from a class. An entity is an instance of an object that has some sort of mapping done to database schema. It is an instance of an object that has mapping provided to database schema. Correct. You can have an entity that's composed of many different tables and many different columns, or a subset of those. So, generally speaking, it's going to be one-to-one. All right, and then removed. So a removed entity is just an entity that's scheduled for deletion. The actual database delete statement will be executed when the persistence context flushes. All right, so now I'm going to go into some basic optimization information about what Hibernate does, both in read and write, along with some tips about that. So one of the reasons why JPA and Hibernate are really great to use is because now your developers don't have to worry so much about SQL injection attacks. Any one of us can write out a raw connection to a database and get the information we need and do that row mapping. And any one of us is going to make a mistake doing that, and we're going to concatenate a string wrong, and our database is owned. You don't want to try to resolve that problem. These libraries are great and have already done it. So JPA, for example, will generate your SQL for you. Just note, and I'll even admit I've done this myself in code, if you're writing JPQL for JPA, you may be tempted to even concatenate those fragments. There is a chance that just by doing that, you may be exposing yourself to some sort of SQL injection. So it's generally a little safer than doing raw SQL, but just keep that in mind, that because you may potentially be taking a string from a client and adding that to your concatenation, and that's a big no-no. In fact, when I am reviewing code, I always take a careful look whenever I see someone do this. Hibernate uses prepared statements exclusively, so this also helps protect against injection. Another optimization that you get is the fact that you're getting auto-generated DML. This is really awesome in the fact that you don't have to necessarily know SQL or be strong with SQL to work with these libraries. Now, you should have some basic understanding underneath about it, but keep that in mind. And you even can go as far as auto-generate your entities. And this is also a powerful way to ensure that generated statements are adjusted accordingly. That may or may not be a good idea depending on your situation.
Generate the classes.
Yes. The question was auto-generating the classes themselves. Yeah, you can definitely do that. The other thing too is that using these libraries, you get application level concurrency control. Now I'm not going to get into, unfortunately, optimistic and pessimistic walking too much in this presentation, but just note that this control allows you to prevent lost updates, and it imposes happens before event ordering when it's doing flushing and batching. The other thing too that is very useful is detached entities can become managed. And if you've done some Hibernate before, this is done through a merge statement. And so this is how you can reuse something that you already have resident in memory and get it back in sync with the database. And then JPA, which Hibernate supports natively, provides pessimistic locking. This brings support for timing out lock acquisition requests or skipping already acquired locks. So if you have some poor performing servers or code, this helps make sure that you're not retaining locks that are affecting other users of the vendor. All right, and then another concept I kind of want to go over quick at this point is the idea of batching. So batching is the process of sending multiple statements in a single request. So think about if you've written any SQL code using a SQL IDE, whether it's SQL Management Studio or Data Grip or pgadmin, you're not usually sending one statement at a time. You're writing basically a SQL script. What's actually happening is you're sending to that database server in a single connection multiple statements for it to execute and then return result sets to you. Now, if you think about the context of your application, this is extremely valuable for you and your performance. Because if you have to go back and forth on every single statement, you're going to have issues. And so with batching, the persistence context is actually basically acting as a transactional right behind cache for you. And as you're interacting with managed entities, it will actually defer any entity state flushing for you up until the last possible moment. Now, this is something a lot of people don't realize that is very critical to know. Because let's say you are making a change to one field in your entity, line 3 in your code, and then line 4 in your code, you're changing another field. Line 5, you're actually alternating what you did on the first field, 6, 7, so on and so forth. It makes no sense for the vendor to go back and forth between the database on every one of those. So what your persistence context does is it's actually tracking the changes that are queued up to be made and checking accessors of those. And it's not sending it to the vendor unless you absolutely need to, such as doing a read on one of these. And so this is the most neglected or improperly used feature that is absolutely wonderful and probably one of the most powerful things in Hibernate that I've seen. If you're not using this right or you're neglecting it, improper batching absolutely will, it's not an if, it's a when, wreak havoc on your application and sometimes even your RDBMS performance. I've written some code even where we get the disaster call from some hospital that this database is going down and they can't view medical records because it's a shared database with another application. You don't want to be in that boat. Do not neglect how this works. Conversely, make sure you're not prematurely flushing. And you may prematurely flush without even know it. So here's some code that I've seen 100 times in code bases and it irks the heck out of me. So you may be using entity managers or Hibernate session or Spring data, doesn't really matter. But in this example, I am grabbing a post entity with the ID of 1. So can anyone tell me what state this entity is? So my pointer to post has an object that is in what state? It's one of 4. What was that? That's a good guess, but what I'll say is I am running inside of a transactional context right now. So, good question. I'm not showing that here. Mm-hmm.
What did you say?
You said detached, which I am saying is not my intent with this slide, but managed? That is correct. All right. So this is a managed entity. And there is a relationship off of this managed entity called comments. So this is probably another table coming from a join, or really depends on what my mapping and my bindings are. And I'm iterating through each of those. And I'm changing a value on those. But first, list of post comment. What state are each of those instances in? Managed as well, that is correct. So all of these are managed entities. And so now what you see is as I'm iterating through these comments, I just want to set that they've all been reviewed by someone. I'm calling the entity manager to merge it. And so what I'm explicitly doing is I'm telling the entity manager, I am smarter than you in your own tracking of changes. I want you to flush to the database right now and get this in sync. let's say there's 10,000 comments on this post. That's going to kill my application performance right there, because as a developer, it makes sense to me that I would actually specifically invoke an operation to get this back into sync with the database. The problem is managed entities are proxy objects. They are not plain old objects. I'm going to bang that into your brain. I think it's in the next slide. No, it's a couple slides down. These are proxy objects. It's already tracking your changes. As long as it is a managed entity and it's not a transient entity, those updates will happen at least when the persistence context decides to flush. Yes?
But just because you say merge doesn't mean you're going to get a flush, right?
It really depends on your configuration. There's a lot to be said about that.
I'm not arguing in favor of that code.
Yeah. You may be protected from a flush. Another example very similar to this that I see a lot is code that there may be some collaborating service, and this code is calling into another service that I could accept a newer update, and at the end of it, it's always doing a save or a flush to your entity manager. And the collaborating service is then making an update to it. Things like that can kill you as well. And that actually I've seen more often than even this. All right. And that's actually what I just talked about. Is this is very, very common to see, and it's just the nature of code. Code changes, and people don't understand what's going on. It looks like a plain old Java object, and naturally, you have to send it to the database. Always remember that you should always monitor for premature flushing, and when you see it, make sure to squash it. It may make some of your services interaction a little grosser, but it's going to make your application more performant, and that's what's key. All right, and then I want to kind of show you an example of some improper batching. And I was going to make my developers watch this presentation, and they're going to hate me for this. But I don't think they wrote it. I think it's predecessors who wrote it. And luckily, I saved a trace here, so we're safe. All right, so I have all of our Hibernate configurations managed through a data source driver called P6Spy, and I have that data source collaborating with Spring Cloud Stream. So I actually see every operation as part of my open tracing, which is kind of cool. And you can see this request here. This is just an API request. It says for sponsored content. And this entire span was almost 0.4 of a second. And we're a very high trafficked site. We can't be doing that on little API calls for something that looks like sponsored content. And I looked into this, and our database connectivity is pretty fast. There's a few long ones, but it's just fetch, query, fetch, query, fetch, query, fetch, query. What is going on here? And this just smells to me that it's not the developer doing anything other than just refactoring some services. They have some collaborating services going on, and they don't realize that they're looping through a list or a set and are causing many different persistence contexts to be created. Luckily, we have a shared database connection through our driver and connection pooling, but if we didn't have that, that would kill us even more. But going through just a few of these, most of these queries don't, like this one here, this doesn't look like this should take any time, and we see that. But this is talking about AM best ratings. Well, that's a rating that an insurance carrier can have, and this is a call to display some sort of carrier as some sponsored entity on a page. Why do we need their rating for that? But it's just the nature of how this code is written that that's being fetched. All right, so does that make sense why it's really important to understand batching and not to flush early? Is everyone going to start looking at this in their Hibernate code? Hoping to see nods. All right. So just to really drive that in, if there's only one thing and one thing only you remember from this talk, a managed entity is not a POJO. It's basically a service interface for you. The other thing that's kind of important to remember is, as developers, we're used to looking at data as models, and this is kind of graphed out into memory. It's really important to know that the source of the data we're working with is not the same model. It's basically a result set that is a tabular representation of underlying fetch data. Keeping this in mind as well is really going to help you really think about what kind of entities you're creating and how you're interacting with them. All right? Any questions so far? I know I'm kind of going through some of these fast because I have a lot of slides here. All right. So another thing to remember on read-based optimization is this concept of lazy versus eager loading. So this comes into effect a lot when we're talking about associations. So some sort of parent-child relationship with our entities. This is joined either through a junction table or foreign keys in your database. And anyone who's seen a visualization of your database schema, you see that it can definitely grow into a very large star. And you may want to map that out. But you don't want to select your whole database, hopefully, which can happen with improper use, that you can get a Cartesian product of your database. So the concept of lazy loading comes into place. So when you're defining your association, you can tell Hibernate in its mapping that this is a lazily loaded reference. This will usually be on a reference to many. And what that does is, when it originally selects your data, it is not going to select that join or that external table or join against it, depending on what your fetch policy is. It will, however, as long as that entity is managed, watch that entity for reads to that field. And if you do read that field, because this is a proxy object, it will then at that point start flushing, because there might be some other operations already queued up, and then perform a select and fetch. This would be very poor for your performance if you already know that you're going to need to select that data, but it's even more so poor for your performance if you wouldn't need it to begin with. And so if you do know you're going to need it up front, this is where eager fetching comes in. So this is when an entity owning an association is fetched, it will send select and join statements for that association right from the get-go. All right? Now with fetching strategies, Hibernate gives you a few options. You can decide to configure these on your own, or you can decide to take the defaults, but it's good to know what's available and what's happening underlying with these strategies. So the first strategy that you can say is you want to do a fetch strategy of join. What that means is when it does fetch, it's going to do an outer join with your select statement. Select, what it will do is it'll do additional select statements. Subselect, additional select statement is used to retrieve the whole associated collection. This is meant for too many associations. In batch, this is where an additional number of select statements is used to retrieve the whole associated collection, and each additional select will retrieve a fixed number of associated entities. And so this is also meant for too many associations. So this is a good tool to use in your toolbox if you see that Hibernate isn't sending the most performant set of statements to your database. You can actually tweak which strategies it uses to collect your data. There's no right or wrong way. It really depends on your data and what you're trying to query. You can do it through an annotation, or you can do it if you're still using persistence XML. All right, so there's two groups of associations. This will make sense. There's many to-one or one-to-one associations. You can use annotations to map these, but if you think about it, it'll logically generate from your database layer a result set record to correspond to a pair of entities. And both the parent and the child can be resolved through each iteration through that result set. So while it's iterating through that result set, both the parent and the child will be retrieved through that. And by default, Hibernate will, if you don't provide a fetching policy, set that to eager. Because you're just pulling one record there, it should be fine. One-to-many or many-to-many relationships. Again, there's some JPA annotations that are available for you. But just note that due to how SQL join works, the result set contains a duplicated parent record for each associated child. And so understand that if you're pulling a lot of data, you're going to have some duplicate data on the wire. I would also say, and this is purely opinion-based, that a many-to-many association, albeit sometimes necessary, when I see it in code, that is a code smell to me right away. Because generally someone will eagerly fetch it, and there's a lot of records there, or it'll be unnecessarily fetched. I usually see a lot of bad code around these. Now, the one place where I have actually seen it a lot pretty well, it was actually what I saw with you the other day. It was around security. You may have multiple groups to multiple roles and those types of mappings in your database, but usually someone's doing the wrong thing when you see it. And by default, both of those will be lazy. All right, so some advice and tips on read-based optimization. It's your responsibility that you're fetching responsibly. So keep that in mind. JPA and Hibernate allow fetch types to also be defined on the entities themselves. If it's possible, opt out of doing that. Because when you put that on the entity itself, what you're doing is you're adjusting the Hibernate global fetch plan. And when you say in that global fetch plan that something must be eagerly fetched, there's no way of overriding that on a query-by-query basis. So try to avoid defining these on your entities. Now, I'll say flat out, there are applications where it may make sense or more readable to put it on those entities. I give in to that, but the expert that I've been citing, Vlad Mahalchia, he'll actually say that eager is evil and you should never, ever, ever, ever use it. And the fact that it's default a lot of times is really bad. So keep that in mind. The other piece of advice that I can give you is think about limiting what you're fetching with projection classes when you're doing read-only operations. So a lot of times when you're making an entity, you're basically spewing out everything that's in your database that you could possibly need to manage. But if you consider like a user in a blogging application, you may only need to read their preferred username. So don't take an object that will fetch all of their comments they've ever made, all of their group memberships they've ever made, all of their login history, just to get that display name. Send in a projection object. You really only need that full entity if you're really thinking about making updates to it. All right. This next section is an important one about identifiers. So identifiers are actually very central to how Hibernate monitors state and synchronization management for entities. These IDs are critical for it to track these things. As you could imagine, it makes sense. However, to support any number of database designs, JPA and Hibernate will support any type of primary key you have, whether it's auto-incremented, sequenced, composed. This is more of an attribute if it's some sort of natural key. Hibernate will let you work with it. And this may be a case you might not have the ability to change this database schema. So you won't be in a bad place if there's a weird identifier. But I would say in general, especially if you can control the schema and if you're designing a database, I would just recommend that always think about using surrogate keys. A lot of developers, they think it's clever. Well, if I combine these two fields, I know that's a unique identifier, and I could maybe get some perceived performance enhancement from the database, and then 6 months down the road, your data model changes and it's no longer unique. Surrogate keys will always save you. It will always save you. It will always save you. I've never had an engineer argue to me when I complained in a code review that there's not a surrogate key successfully. Yes?
What exactly do you mean by surrogate?
So let's say a good example is, let's say I have a bunch of people managed in my database and I happen to know their social security number. And I know every record in there will have a social security number. I could say, well, that social security number is unique. I'm going to set that as my primary key. Now 6 months down the road, you decide, okay, we're going to be supporting other countries now, and they don't have social security numbers. Now you're going to have to rebuild a lot of indexes, form key relationships. It's going to destroy your database. So what a surrogate key is, it's just an ID that's placed on top of your table, just called ID, depending on the naming conventions of your database, what it's called. That is the primary key for that record. It doesn't mean anything. It has no meaning to the data itself. It's a surrogate to your data. All right? The other thing is, if you do have a lot of flexibility with your data, I also recommend to think about using UUIDs as your primary keys. Now, this won't always be possible, especially if it's a database that needs to be troubleshooted a lot and no one wants to read off a UUID and type it in exactly. But if it makes sense, use UUIDs. And the reason for this is because identifiers, as I said at the beginning of this slide, are critical to how Hibernate maintains state and synchronization management. Hibernate works best if it can provide the identifier for a transient entity. If this is defined by the database vendor itself, this means that it may have to flush earlier than it would normally do. It may not defer some operations because it now needs to get that identifier from the database. However, if it can provide an identifier that it knows is unique, because it is a transient entity, it will really save on some round tripping. The next best way is maybe through a database sequence, configure a sequence generator with Hibernate. And so this will, as I said, be driven by some sort of atomic sequence. And what Hibernate will do is it will use that sequence generator even outside of the persistence context where it's needed, and maintain a bag of IDs that the database gave it, that it knows that it can hand out to transient entities. This is also fairly performant too, and it's highly configurable. You can configure what these allocation sizes are, so on and so forth. But just note, and there's a lot of times where I've seen this used where someone will specifically configure it with an allocation size of 1. And that just irks me. Like, what's the point? What? Because now, in every persistence context, on every transient entity, it will go to the database and round trip just to get an ID so it can manage state. Usually when I see it, like I'll right-click and look at the Git history, and I'll say, oh, there was a defect that ID numbers are skipping in our sequence in the database, and it makes it hard to troubleshoot. Like, if these are surrogate keys, does it matter? It doesn't. If you're scaling out 2 services, yeah, one will have 1 through 30, and one will have 31 through 60. Who cares if you're using surrogate keys? Your surrogate keys don't matter. So that's my slide on identifiers. Any questions about identifiers? Yeah.
If you start using like an insert row, is that guaranteed to be like database auto-incremented correct value right away?
Well, I hear the word auto-increment. And so what I'm guessing is you have a primary key where the database engine is doing an auto-increment for you, like SQL Server does this. Hibernate will support that, and you can do that. But what will happen is you have to say this ID is generated on the vendor. And when Hibernate needs that ID for its management, it's going to flush this insert earlier than it may have otherwise done because it knows it has to get that identifier from the database. Now, every vendor, including SQL Server, will support you making some sort of atomic sequence to query. In Postgres, for example, I've done it where I've said if the ID is provided, use it. If it's not provided, hit a sequence. There's tricks in SQL Server 2 to do this that I wish I knew back when I worked for my last employer. It'll work if you can't work with the database administrator. Just note it's not going to be the most efficient. Good question.
Can you elaborate a little more on that second last bullet point? Is that a Hibernate specific thing?
I believe some other JPA providers will do that as well, but Hibernate definitely does this.
So what does it just keep like a pool of them?
Yeah, so let's say you configure sequence generator, you have a table called post, and you have a sequence in your database called sequence post ID. You can configure a generator through an annotation. Oftentimes you can just put that annotation right on the entity itself. But it is a separate service inside of Hibernate. And what it will do then is it'll actually hit that sequence outside of even the persistence context and just hit that sequence like 30 times if that's your allocation size and keep that bag of IDs available in memory because it knows they're unique because it hit a sequence. Now, if your service, is sig-termed or something else, yeah, those IDs will never be used as long as that table is always managed by Hibernate. But who cares? Yeah.
I had a quick question. So if you had a composite key that you're doing, because maybe the schema already existed,
Yep.
and you're creating a new entity, does Hibernate have to go out prematurely to make sure that it's unique before it allows you to insert, or is it going to blow up your whole?
Well, not necessarily unique, but it's going to have to do some flushing to get the information about that ID so it can start managing the state. And so, yes, that would cause you. Now, it'll work great, and it may be very performant. but this is about looking for places where you can improve your performance, so this is a big one. Generally, with composed keys, usually my only problem with that is static analysis will usually bark at you if the composed ID class isn't serializable and things like that. And that's actually is a little important to Hibernate. I don't know all the ins and outs of it because I tell people don't do it. But I have more control over the schema than some people do. All right. So now I'm going to go into relationships. So the first one, many to one. You can choose and you have total control. This is always going to be the most performant relationship with Hibernate. And because a many to one association controls a single foreign key directly, automated statements are always efficient. And as I said, they're always the best performing. The thing to note, though, is a lot of times as a developer, when you're thinking about hierarchy of an object, you'll typically go from the top down. And you don't think about the fact that actually the child might be the direction you want to go to get that parent. So let's just look at some sample code here. So pretend, for instance, I have a class that's a post comment, and it's a child of a post. And so on this post comment, I have a many to one relationship to my post table, and I'm using a join column. And I write some code. So what I do is I call my entity manager inside of my persistence context, and I say, get me the post class with ID of 1. Let's make a new transient entity, post comment, and I'm going to set that original post I got, which is managed, onto my comment. And then because I have a transient entity, I want to tell the entity manager that I want to persist it and make it managed. And so I'm going to persist my comment. This is all the SQL that Hibernate will generate for that. Very efficient. It's just going to say, okay, there's already an existing post entity. I know because it was managed by me and it was fetched. And it has this ID of 1. And so this new transient entity, which needs to be managed, I'm just going to insert into the table and set up that foreign key relationship. I'm good to go. Make sense?
Is the default a join, so it doesn't outer join when it has a many to one relationship? Did I sleep through that?
Nope, it's okay.
I'm punishing the class. Okay. Sorry.
It really depends on your fetching strategy. I would have to look up what the default one is again for that. Nope, it's all right. I probably didn't need to go all the way back there.
Well, here's another question. Do you know, like, if it were a non-nullable foreign key, the inner join would be a faster fetch, right, against the database rather than outer join. But my preference is to say use an inner join if I know it's a non-nullable foreign key.
Yeah, you have control over your fetching policies. You'll want to refer to the documentation and look at what it's doing.
This book sounds like a good read reference for that stuff.
Yeah, absolutely.
Yeah.
Highly recommend it.
Cool. Thanks.
Yeah,
All right.
There's actually so that book's good. I think you can get it. I have one on Meetup, which I believe is the same author. It's pretty cheap, and it has like the same amount of depth into Hibernate. Like this guy's ORM genius.
And he's written a lot of the Hibernate core code, and
So you can get it like tonight if you want it on Meetup. It's a good
he
book.
starts all the way from the JDBC layer all the way up.
I'll send out links to it in the notes.
Yep. All right, another thing to think about with many to one is, let's say I want to remove my relationship. So I have this managed entity comment, and I want to say its parent's null. This comment is not on a post anymore. Well, it's managed, so I don't have to call any persist or merge or anything. And I just set a null. So the generated SQL is pretty simple. It's just update post comment, set post ID equal to null, and where the ID is 2. Makes sense? All right, now let's dig in a little more to a bidirectional one-to-many. So when I'm talking about a bidirectional one-to-many, this means an entity on one side has many-to-one, the child, and the other entity has one-to-many. So when it's actually making its global fetch plans and doing the global persistence mapping, it will actually see that this is bidirectional, and Hibernate will leverage that. There's a couple things to note, though, when you're leveraging this, is if you don't have an ID on these entities, it's going to be using equality-based entity removal. If you have to use this, let's say your DBA won't let you put an ID on this other table, always implement equals and hash code on that entity, because not doing so, Hibernate will fall back to a reference in memory for that entity, and that may or may not be valid anymore if you've crossed and left persistence context bounds. If you do have an identifier, you want to provide equals in hash code, but you have to be very, very careful when you're doing this. A lot of it's going to depend on if you're using sets versus lists. It's going to depend on what your data looks like, if you're expecting a lot of rows, if you're eagerly fetching it, lazily fetching it. But everyone hates writing equals and hash code, and so naively, on a database entity, you may use object equals or object hash, or Lombok, which I love, has this annotation at data. You have to remember that this has to be reflexive, symmetric, transitive, and consistent. So think of a transient entity, for example. You may not have an ID yet. You're waiting for that. And so what if you use that ID in your equality check? That is going to inadvertently affect how Hibernate does removals from these sets and lists. It could be very bad. What if your child entity has its own association with other entities, and those are lazily loaded? And this is maintained in a set, and so Hibernate's going to be using a hash set, which we'll be calling your hash code method. And if this is generated, that's going to read into this other association. And remember, this is a managed entity, and this is lazily loaded. Now you're, just to check for equality, you're making new fetches to the database without even knowing it through an annotation. So always watch out whenever you're using these awesome helpers on your actual Hibernate entities, how they're being used. And there's no silver bullet way. My developers have asked when I've introduced them to Lombok, and then I saw them on entities, I said, be careful. Like, well, how do I know? What are the rules? And it's like, you have to think about your data. And you have to think about what's happening on the wire there. And you have to think about your fetch strategy. Yeah?
Oh, quick question. So, I remember what transitive and consistent mean in symmetric, but yeah, so A equals B, B equals A, transitive A, if A equals B, and B equals C, basically A equals C, but I don't remember what reflexive means.
That you should be able to do this in reverse.
Oh, so A equals B.
Oh, that's
B
symmetric. This is getting into an area that I should know like the back of my hand, but I did not restudy that.
That's what
Yep.
maybe
But like a good example, like I said, is the ID example. You may not have an ID, so in your equals, check if it's null or if they're the same. All right. The other thing you need to also remember is there's serious implications whether you're dealing with a set or a list. When you're using a set, it's going to really dig into your equality checks and hash codes, just because that's the nature of how hash sets work. But on the other side, if you're using a list, Hibernate's going to really be concerned about order. And there's going to be situations where either one of those might shoot you in the foot. So keep that in mind. When you're using bidirectional associations, they're also generally efficient, as the many-to-one mapping is in charge of the relationship in Hibernate's view. So keep that in mind as well. All right, so here's some sample code. So this time I'm on my post class, and I have a one-to-many to my comments. I have a list here. That's one thing to note here. I'm dealing with a list. And so here's some code. I have a new post, so this is transient. And I have 2 comments I'm constructing, also transient. And I'm adding each of those to my post. And I call the persistence context. The entity manages my interface to that. And I say it to persistent. So this is generated SQL like it comes out of that. Seems pretty efficient and probably the way I would write it if I were directly on my database vendor. All right, okay, again, the same class. Now what I'm going to do, this is assuming the same data I just put in, that I'm going to remove comment 1. It's again pretty efficient. It's just going to delete from post comment where the ID is 2. If you remember right, it's inserting the value 2 on first one. All right, next up is unidirectional one-to-many. So this is where you're using that same annotation, but the child doesn't have a many-to-one coming back. Avoid this if it's possible. It may not always be possible depending on how your code's organized, but avoid it. Oftentimes, it's, again, how developers naturally think, from the top down. This may be tempting to use. Why does the child need to know about its parent? In the end, 3 joins will always be required for reading instead of 2. When you're adding, 2 tables must be written to instead of 1. When you're removing, all child entries will be removed from your database and added back again. Because Hibernate doesn't know enough about your data to do anything different. If you're using an order column, because again, thinking of a list, this can help improve efficiency a little bit, especially if you're treating this collection like a stack, because you can avoid having to remove all of them from the database if the element is far away from the head of the stack. But the closer your removed entity is to the head, the more it's going to remove. And I'll show you that in a moment here. The other thing too is instead of doing one-to-many, there's another annotation that's available called element collection. That's used a lot. You might have another table that you just want to map to a basic type like string or integer. So this is the annotation you use with Hibernate to do that. But underneath the hood, it's basically still just a unidirectional one-to-many. All right, so here's an annotation again. Looks a little different, but largely the same. And you've seen this code before. I got, this time, 3 new post comments on one new post. All of them are transient. I turn them into managed entities by calling my persistence context and calling persist with them. This is what will be generated. It's going to insert into the post table. It's going to insert into the post comment table 3 times. And then in my junction table, it's going to make 3 insertions. Now, after these are managed, later on, I maybe still have it in my persistence context, or I refetched it. I'm going to remove the first item in that list. And what will happen is it's going to delete from my junction table, where the post ID is 1, and it's going to reinsert every entity and then delete from the post comment table where it's 2. Remember, 2 was my first ID. Not the best. Now, if you use an order column, so you see that extra annotation, you can give a hint to Hibernate saying, hey, I have another field on my database. I'll actually tell you the order. That'll help with efficiency some, but in your insert, you'll see that it's inserting this entry order. So in this case, I'm going to remove item 2, so that middle record. So pretty efficient. Now it's not basically deleting from my entire database and rewriting, because it knows, based off of that list, removing 2, it's at the end.
If you have a foreign key constraint,
Foreign keys are different than the junction tables. This is work on junction tables. I do have some slides
cool. Thank you.
on that. Yep. Now again, ordered's not going to help you all the time. In this case, I'm going to remove the first one. I'm going to remove the head. You can see it's just the same. It's going to delete from the junction table. It's going to perform that update and then delete again. All right, so one of many with a join column. So a join column annotation allows you to control your associations by a foreign key and eliminate the need for a junction table. One thing to note that from a performance perspective, it is an improvement over regular one-to-many mappings, but usually in practice, it's not as efficient as a regular bidirectional one-to-many association. Really think about using the bidirectional ones if you can. All right, so you'll see the same code we've seen, and now I'm saying join column. I have a column called post ID. It's a foreign key. And again, this time I already have a managed entity of post. I'm adding 3 comments to it. And here's the generating SQL code. Make sense? All right, this time I'm going to do a remove. And in this case, you can see now we're starting to get back to being a little more efficient again. You can also use a join column on bidirectional, and it basically works as you would expect from the previous slides. I'm not going to actually show all the examples and what's generated again. But just note that if you do this on a bidirectional one-to-many, that your child side should be instructed to avoid any insert and update synchronizations. And an example of doing that is on your join column annotation. You can just say it shouldn't be insertable and it shouldn't be updatable. Is everyone following? Seeing some nods. That's okay. Stuff is tough and you got to practice with it a little. Now, I talked about how many-to-many is kind of bad, and I've also, if I had all day or all week, I'd go over to what many-to-many looks like when it's generated, but I'm going to avoid that right now. Just note that they're very difficult to maintain, but they're very easy to rejigger your code to treat as a one-to-many. And basically, what you can do is take your junction table and just make it an entity itself. And so if you think about the idea of a post having many-to-many relationship with tags, just make an entity called post tag. And now you're managing the junction table just the same. But more importantly, you get out of many-to-many world, and now you're back into one-to-many. Make sense? All right, so I know I've been talking for a while here. My clock says an hour on here. And I can tell you right now, many of you probably came here wanting to hear about such and such, but I didn't talk about it. Again, there's only so much I can go over. So I'm just have a couple slides on some places you should look at next where I would recommend. A very interesting area that has fundamental implications to your application is how you're doing your connections and your pooling and what data sources you're using. Ultimately, if you're naively doing this, you can really starve your application of connections, or conversely, place too much load on your database vendor. So it's important to kind of look at. It's often overlooked, or people just put in a magic number. I'm just going to put a connection pool of 20. There's some math you can do if you understand the characteristics of your application. I'm trying to figure out what a good size is. Hikari is a library that's also right now the best right now for connection pool management. Latest version of Spring Boot does actually default to it, which is nice. Vlad Mahalchia has another one called FlexiPool. Recommend looking at that one as well. Another library, now the reason you use it isn't to get to your data, but it's implemented as a data source. It's called P6Spy. So P6Spy has been around for a long, long time. It'll work with your Java EE application servers just fine. But it decorates your data source. It's your decorated pattern, and it'll actually give you performance metrics and even raw queries and fetches from your database. Very handy. I actually prefer it better than Hibernate logging, which is good when you turn it on. But if I want to see what the raw SQL looks like, let the data source just grab that for me and log it out. And then I can copy it into my favorite SQL database client. Now, it only has like, I want to say like 60 or 70 stars on GitHub, but there's this library here that I use it extensively. If you just Google Spring Boot P6Spy starter, it'll come up. This Spring Boot starter is a great way to start bringing in P6Spy. And if you're using Spring Cloud Sleuth and doing tracing, it will just right out of the box add every database query and fetch as a span in your trace. And in fact, when I was showing that example earlier, that's how I was doing that. Another big topic with Hibernate is how to deal with inheritance. There is a lot of things you can do with this. The idea that your inheritance might span multiple tables and you're really typing these. It's an interesting topic. It may be used for you. My humble opinion, just don't do it because it can be a pain point as your database is refactored. I've seen cases where I just really hate predecessors who've written it that way. Flushing, again, entire chapters and entire days can be dealt with on how to deal and reconfigure and optimize flushing with Hibernate. It's also a very interesting read. Batching as well, and caching. There's a plethora of different caching services that you can use with your database. Hibernate supports them as second-level caches. They're very useful for read-only operations. There's dozens of libraries out there that help you do this. If you're in like the old Java EE land, you might be using Infinispan or EHCache. There's a lot out there. And concurrency control. This is probably one area where when you start seeing exceptions, whether it's optimistic locking exceptions or pessimistic locking exceptions, where you're really going to tear your hair out, like Hibernate's really annoying you, this is where a good opportunity to read about concurrency control. One of the best ways to do that is use a field on your entity that you're annotating with that version to help you with that. And you can read up on that, as well as those exceptions I just talked about. And that's all I have. I said I could go on for days, but I thought this was a good baseline to kind of really understand underneath the hood what's going on and give you a place to go. So, any questions? Yeah.
You talked about how an ORM will put off actually writing the database until it's absolutely necessary. The opposite of that is, suppose that you have something that you know you want written right now, and I really mean right now. What's the best way to do that? Entity manager.flush? Because that won't always, just because you ask it to flush doesn't necessarily mean it will either, right?
Sometimes it won't for good reasons, but that is the best way. Ultimately, though, a big reason why you might not be seeing it when you're calling flush is you might be in a transaction that's not committed yet either. And so you are probably actually flushing right away. In most cases, there are some edge cases where you aren't, but you're probably not seeing it in your database because you have to commit your transaction.
So in other words, you might have like a -1 or something. Something is still a transaction, and so it can't be flushed yet.
Well, what you're saying is there's some relationship that's in a transaction and can't be flushed. Really what I mean is your persistence context is a representative of what your entity states are. And if you're inside of a transaction, just like if you're connected to a SQL client, when you say flush, what you're saying is send all the statements you're ready in the appropriate order to the vendor, as well as getting the fetches back. And so you may be actually sending that statement to the database vendor. But at the start of your persistence context, you began a transaction. And so just because you're flushing your current statements doesn't mean that you've sent a statement to commit your transaction yet.
Yeah, that's where like vendor-specific stuff would come in. So if you're on Oracle, you could say there's different transaction levels that allow dirty reads from other queries. But if you're on Postgres doesn't support dirty reads, so you're never going to get that. So that's where you can do like transaction isolation levels, but it also depends on the vendor. And you can set that in Hibernate too. You can say like auto flush.
We were on Postgres.
Yeah.
Yep.
So it's like I like Postgres, and they don't allow that for a reason, but sometimes I'm like, well, it'd be kind of nice if they allowed that.
Ultimately, if you want to see if this is really being flushed or not, pull in a tool like P6 file. Because if that statement's getting sent, you will see it as a P6 file. Instead of trying to understand Hibernate logs, it says it did it, well, did it or not. Well, the wire doesn't lie to you, and that's what P6 file is going to be.
I'm wondering when eager is not an eager fetch. On a many-to-one, I'm wondering if there are also some database-specific thing or database drivers that Hibernate may not interrogate properly or may not give Hibernate enough information to support the eager.
I mean, that's certainly possible. It may be possible, depending on what your persistence findings are, that you may unknowingly, maybe even through a field and some object, it knows it's going to need to fetch that data anyways. There's also cases where I'm trying to remember, I thought there was a time in Spring Data, where it was configuring things eager when it didn't necessarily need to.
I was trying to get to eager. In order to do one SQL read on an entity, and I could not get the database to do it, and I had to resort to query annotation.
So that if you're using the query annotation, you're still using, was it native query or was it JPA query?
No, I think it was JPA. Yeah, JPA query.
Okay, what I'm guessing you probably did in there is had some sort of fetch join or join in your annotation that modified the entity graph for the fetch plan. And that's actually a very appropriate way to do it, to coax the type of fetch type you want. In fact, even Vlad would recommend that versus
I tried
annotations.
that, and it wasn't until I did the query that I got it down to one SQL statement. Otherwise, reading one entity would result in, 3 to 5 or more SQL hits. So I was trying to optimize the read down to one.
Got it. Yeah, then what you probably want to look at is your fetch strategy. So remember how I was showing that table of fetch strategies, explaining depending on which one's being used, whether it's doing an outer join or whether it's doing subselects. Yep. Take a look at those, but ultimately your JPQL that's in your query parameter will also kind of define some of that strategy for Hibernate. So.
I've had an issue too where you're doing everything that the docs say to do and it's still not coming up with what you want. And I've found that's very finicky between the JPA provider and like what database you're using. It also can depend on like defaults, like hidden defaults, especially if you're using Spring. It has a lot of baked-in defaults that you need to know, like to override, like global eager or global lazy or weird things like that. So yeah, you kind of just got to push around with it till it works. So it sounds like you found something that worked.
I personally done times where it made sense to put like a eager annotation on an entity, but if you take Vlad's advice to say just turn eager fetching off altogether, then at least you're in a world where you're consistent, where you're always telling the query to fetch, and that might be helpful as well, instead of trying to discern between the two.
Does Hibernate check this in an update if the database has been touched, or is that the version you use for?
You can use @version to help with that. So sometimes you might just have it as an incrementing integer or a timestamp.
Yeah.
You can do some configurations depending on your vendor to do actual lock inside of the database itself on the row. There's a lot of options, and it's literally a topic that would be an entire different presentation.
Right.
So, but yes, all those are available, and your easiest way to get started is researching in @version.
Any other questions? questions? All right.
So the one last thing I was going to say is after this presentation I'm done here, I was going to go, there's a bar called Tide House on Water and Erie, and if any of you are interested, I'll buy the first round for everyone. So, all right.
Sounds good to me.
Cool. All right. Bye.
Thanks a lot, Adam. Great presentation. I found a lot of use out of Hibernate over the years, so I would say if you haven't used it, try it out. If you have questions, I'm sure I don't want to speak for you, but I'm sure you'd be available for questions offline too. And feel free to ask me any questions about Hibernate and GPA as well. Does anybody want a JetBrains 1-year license key? Raise your hand. Who would like to be in this drawing? It's 1, 2. Anybody else? All right, so we got 2. Hold on. Does anybody have a coin?
Quarter.
All right, we got a quarter. All right, Jeff, heads or tails? Heads or tails? Tails? Heads. Sorry. All right, just leave them with me and I'll get your email. All right, thanks everybody. We got some actually really awesome stuff coming up over the next few months. At the beginning of April, we have Dr. Jeremiah Rossler. He's coming from Germany. He's going to be in town, and he looped up with me and said, hey, I'd love to give a presentation on test automation. He is a CEO and open source developer for Retest, which is a test automation framework. I think it focuses on Swing applications and GUI desktop-based applications. So that'll be really interesting. And then at the end of the month,
I'm sorry, did you say GUI desktop application?
yeah, I don't know if it works for the web, so we'll see.
They still exist.
And then at the end of the month, I'm working on something pretty big, a presentation possibly from somebody you probably all heard of from Pivotal, so I don't want to announce it yet, but keep an ear up for that one as well. Thanks.
I mean, you know me, I'm a big fan of GUI desktop application.
I know, when I was telling you about it, I was like, Glenn's going to like this.
About 3 or 4 months back, Pivotal actually just gave us one of their projects.
Really?
They gave us a Spring Cloud data flow, the Mesos implementation.
Okay.
So like just right now we've only just like basically just rebased to keep it up to date. But anyway, I was like, you guys realize you're giving it to a company with 6 engineers, and you see it in the Spring blog, hey, trustedchoice.com will take care of it.
Yeah.
We'll try.